GM, welcome to the very first Protocol Explorer Livestream. And at the premiere livestream, we have the one, the only Billyjitsu, who looks nothing like the B profile picture.
Yeah, people meet me in real life. It's like, you're not really a bee. I haven't got my operations yet to add wings and shit. when the bull market comes up, I'll get a stinger. But yeah, good to be here. It'll be exciting. We're gonna do some like live coding. We're coming in fresh, right? Like you haven't seen anything about API3 before.
Nope.
So it's really a testament and a test of my DevRel abilities to see how well we can get this figured out within the hour, and then kind of explain. For those that don't know me, I'm a DevRel for API3. I code a lot, answer a lot of questions, and I talk a lot of smack on the internet. I also do some workshops for Developer DAO and a lot of community events too. So good time. I love the EVM space. Looking forward to today.
Nice. Yeah. I'm going to assume people know me because I'm amazingly famous.
We'll see. But yeah, we can jump right into it, learn what API3 is, and then we'll get to coding on there. And we'll have a couple links in a little bit for everybody that wants to follow along with the video or just hang out and watch on there.
Nice. So I'm going to let you kind of take it from this spot.
Awesome. Okay. So API3 real world data feeds from Web3 straight from the source. What does that even mean? Like, it's basically, we don't act as a middleman. The data feed comes straight from the actual source or the API right to you directly, right? So we don't rent data from someone else and then deploy it back. It's just straight, like the farmer's market of APIs, basically. It's like straight from the API. All right, so today we're going to be using QRNG and the APIs, kind of like powering GameFi. We're going to make like a little kind of like lottery, or kind of like, I don't want to say gambling, but like a risk 50-50 chance of an app using the first party oracles. We say first party because it's, again, straight from the source. QRNG is random numbers. The APIs are price feeds. That's what we call them. Why? I don't know, but that's what we call them. All right, who's this guy? I already did my intro. I'm developer advocate for API3 team, and we're going to create like a high-low example. Basically, like we're rolling a dice, and if we're higher or lower, we win it. All right, so what does API3 support, right? We have currently 3 services, soon to be 4. Our one that people don't really know about is Chain API. That's the ability to bring your API and bring that data off-chain, on-chain, right? Using like our AirNode system. All of them actually all do use the AirNode systems. The other product we have is QRNG, which is what we're going to be using today. It's basically being random numbers off-chain and then bring them on-chain. There's no token required to make that work. You don't have to buy any arbitrary token. It just costs gas. And then we have the APIs, which is our latest product, which is price feeds on-chain, constantly live updated. And again, no token to read that data whatsoever. And our 4th product that will be coming up, there's been a lot of talk about it, will be OEV. The ability to like do Oracle extractable value, basically force updating a price feed to do like liquidations for good, in a sense. All right, so the workshop breakdown today, key learning points for Rahat is going to be QRNG and AirNode. Basically, we're going to bring a random number on chain using the request response protocol, and then we're going to do some price feeds just to check our price to make sure that when we buy a ticket, it's a certain amount that we set in price. All right, real quick, what is an AirNode? Basically, we have these contracts deployed nearly on every chain we support that has the ability to speak to offsite APIs, or basically AirNodes that you can run like on, Amazon Web Services, Google Cloud, and then call that through a smart contract and then pull that data off chain. Basically, we automate that with the random numbers and the price feeds for you, but give you the ability to do it yourself. So you can run your own AirNode for whatever you want, and you can host yourself. It's permissionless, so we can't stop you. You just do it. What are DAPIs? Basically price feeds, right? So they're all chain specific. We don't, bridge price feeds over from other chain to chain. They're all deployed on the chain itself. And so we basically prove that it's data feeds that we have aggregated, and it's reverse engineerable, so you can prove where the data feed came from directly. So like, if it's saying it's coming from CoinGecko, how do you know it's true? You can check our data feed ID. I have like an online script that you can verify to say, oh, this one came from this price feed. Excuse me. And so again, we're going to mix QRNG, we're going to mix DAPI price feeds, and we're going to put that together for our high-low chance contract. Just a quick screenshot out. If you want to check out the GitHubs, we have tons of examples. I write a ton of MVP ideas that might have use for random numbers, for price feeds, borrow lending contracts or staking contracts. They're all in the API3 ecosystem, both in Rahat and Foundry. You can always check out the forums if you want to chat on the forums, if you like governance. And then Discord is where all the questions happen. That's where all the fanciness stuff. But let's not be boring here with the PowerPoints. Let's get into the building. I'm going to stop this presentation. This is going to be Rahat show. We're going to show him, how to build the basics of here. We're going to start it with the simple step. We're going to take that baby step. Then we're going to take a bigger step. And then we're just going to build that whole dApp. And we're going to make this magic happen. I've uploaded a couple GISTs for us to follow along. I know, Rahat, you have them. I don't know if you want to paste them in the chat. But we can just kind of like copy and paste it and kind of talk you through the code to get you to understand like how this all works. I think you're on mute, Rahat.
Yes, I am extremely good at live streaming. Cool. Should we start with that first gist you sent me?
Yep. It's basically the price feed on there.
Well, I actually had a question. Ooh. It is not
is it private
for public consumption.
Uh-oh. This is live stream problems here. It should be a public gist. Let's see.
This is why people don't live stream.
This makes it more fun, even better. Yeah.
See, as y'all can see, we mess around. We are not serious. We're just having fun.
All right, let me create a brand new one on the fly.
Let's go.
And then
so while you do that, I actually have a question.
Go for it.
So price feed stuff makes sense to me. I've actually had this question come up a couple of times from folks.
Mm-hmm.
Why do we need a random number generator?
An excellent question, and something that I didn't understand myself is, okay, so when you run a validator or like, MEV, anybody that's heard MEV, you can basically run simulations on a transaction because the blockchain is deterministic. So like if you're using like block timestamp, wallet address or something, you know what that number is going to be, right? So if we have a lottery, say, hey, the winning number is going to be 53, because we read it through the smart contract, we know that then, okay, that is 53. So I'm just going to keep running the validations and run that contract until I get that number, and then I can exploit it and then win every time and do that. So like it's unfair and doesn't give anybody else a chance that's not running a validator that can run that transaction. Try this one around just real quick. I'm just going to make sure that's a public one too, but I'm going to make sure that looks good. So what we do is with a random number is we send that first transaction to do a random number, and then we then shoot it out off chain, right? And so there's multiple sources of random numbers. Right now, our primary one is Australian National University of Quantum Numbers. They have this huge machine that like has this like one like ping pong ball come in and choose a side like randomly, like depending on gravity and the wind and whatever. And so like every so often, like they just have these random balls, and wherever it falls, like one of those multiple things that like fall, those games that just totally at random. And so they generate a big number based on those randomness, and then they air node that out. So when I run the transaction, I send a request, and then a few blocks later, now the validator can't roll it back. Then the number comes in, and then it's a true random number because then they can't roll it back, and we don't know what it is until we get it, right? And then with that number, it comes back into your smart contract, and then you can do whatever you want with it. So if you do anything within the same transaction, I can already deterministically say, oh, it's going to be this number, and I can keep retrying and then doing it. So then that way you can get exploits. So that's why we see so many exploits of like, oh, here's this lottery, and then this one MEV bot like takes the whole pot, right? It just with a one shot. Yeah. So that's kind of the reason why we need that.
Protect your gambling, folks.
Yep. Yeah, pretty much. And then for gaming, right? Like,
for gaming.
If you're playing for like the magic sword, right, and you pay $10 for like a chance at a magic sword, you can be the validator, and it's like, all right, I got one without, before anybody even has a chance. Ruins your games, ruins the funds, Yeah.
Cool. So I'm going to go ahead and make a .so file data feed reader example.
Excuse me. Yep. So this is pretty much all you need to read a data feed.
Copy this over. I'm going to assume that this is good code,
Yeah.
even though Remix is telling me never copy and paste. I'm going to ignore you, Remix.
That's okay, man. Don't worry. It's like taking workout advice with somebody with a BBL that's 22 years old. You know, it's like kind of fishy. All right. It's a little small for me to see. Can we boost it up just a little bit? Okay.
Up.
Yeah. For so those watching along right now, there's been, you know, with Open Zeppelin 5 and 0.8.20 and up, they require the push 0. So what I did is I did it open basically at 19. So then anybody that wants to push it to a specific particular chain that may not support push 0, it'll work, right? And so if you look at the line 5 import Open Zeppelin, I have it at 4.9.5 just after the contract. Nice. That's how you can import it into Remix on there. For those that use Hardhat or Foundry, you know, you just basically on the npm package, you could do it that way. But that way we don't have to deal with any of the issues or anything. You could use the latest version if you want to, but for simplicity, we're just keeping it like that. So all the examples will have that import, and it'll always be up to 8.19. If you want to do 8.23, then you have to use OZ5, and then make sure that, you know, if you deploy legacy or anything, you have to do like push 0 support and whatnot. So anyways, with that out of the way, yeah, DAPIs, price feeds. How do you get a price feed? There's nothing really magical about it. Is we want to find a way, like, how do we choose a price feed? How do we read the price feed, right? And so that's what those two functions are. And so with API3, we've made it really, really simple to do that, because sometimes trying other feeds, there's like, you have to do all this extra stuff, import, interface, this and whatnot. Basically, it's just one line, which is import number 4 is basically interface iProxy, right? And then you don't have to like make it is anything. It's just part of the proxy. The only thing we have is ownable for the Open Zeppelin. And we're just creating a global variable. So we're going to choose one price feed. That's just going to be our address, which we call proxy addresses. That's how we label our addresses. And so we're going to set that. So we can choose if we want, you know, ETH USD or wrap BTC USD. So we're just going to set that in a contract. And then the second function is to read it. Now that we set it, now we're going to read it. And then we're going to get a return on that. And so I noticed that on the NuGIS, I did not copy the marketplace. But if we go to API3.org, and then explore data feeds on the big blue button on the bottom, you can look at all the data feeds that we have out there that support multiple chains. They're all chain specific, like I said. And so like, I'm assuming we're going to go like ETH USD. That's probably the easiest one that everybody kind of knows. See on the top left, you can just search ETH USD. You're on the left, Rahat. And then that second one over, you can check it. And then depending on the chain that you want, I'm assuming we're going to go testnet, maybe Sepolia or something.
Yeah, we can do that.
Yep. Okay. So then on
Let
under
me
the
see
price,
what chain Metamask is on. I'm currently on Base Girly.
Base Girly. Okay. So we can work Base Girly. So let's go here. And then underneath that price feed, ETHUSD, if you scroll back up and then drop down to the left. Yes. And then we're going to look for Base Girly. And there we go. So if we want to get this price feed, we're going to go ahead and go ahead.
It says Base Testnet. Is it on Girly or is it on Sepolia? Okay.
Yeah, it's Girly. And so just, I mean, based on this, you can see like, all right, here's the price feed. If you scroll down, you can look at the sources. You can see who's providing this data feed right now. For testnet, we only do one data feed. On the mainnets, we do an aggregation of multiple data feeds. So in case one goes down, doesn't destroy your entire DeFi product, right? These are the self-funded ones. So let's scroll up just a little bit to see how much gas it is. So like there's a little bit of gas left, but basically every time we update a price feed, it costs gas. Right. So when you do the paid sources, we manage that. API3 manages to make sure that you never run out of gas, and it has the multiple feeds. The cool thing about this is if one dApp or the chain buys a price feed for that, so they buy ETH USD for like base mainnet, the entire ecosystem can use that absolutely free.
Nice.
So it updates, and that's the price. Everybody can then pull that data.
So it's like a shared cost across the ecosystem. Okay.
So either the chain can do it, or dApps can do it, or one dApp can do it, and everybody can leech off of it, whatever. But you're good to go. It's not limited. It's not token gated. Everybody can use it. So we're going to want to grab the Proxy contract address just below the connect wallet thing on the lower right. That's going to be our address for ETH USD. So if we deploy this contract, and it should be compiled, ready to rock.
It compiles.
Yes. And then we just push it out there. It should be really minimal gas.
Yep. Pretty low on the gas.
All right. And then if we maximize that bad boy contract, and then we're just going to set our price feed to ETHUSD. And again, we're limiting that to only owner, right? Because if you're setting price feeds and someone overrides your feed, you don't want that switching to like wrap BTC or something, And so we're just going to update that price feed. So now our contract knows we're going to read ETHUSD. And so now all we have to do is actually read the data feed on the blue mark, I think on the bottom. And lo and behold, it gives you two values, right? It gives you the price of ETH in the 18 decimal format, and then the timestamp it was last updated. Timestamps are important, really easy to get, right? Like, okay, I got my feed. That's what I need to do. You can check the timestamp. Was it updated in the last 24 hours? Was it updated in the last hour? Depending on the needs of your smart contract, you can make sure you don't have a stale price, and then have, code that thinks, hey, if I don't get an update in 1 hour, shut down the whole thing, or jump over to another feed, or whatever you need to do. Pretty simple, right? Like, you just get a feed. There's nothing too fancy. Like, we did it in like a few minutes. Scrap it. That's the DAPIs. Get rid of it. We're masters of price feeds now. We can create a whole new
there
one.
we go. I'm putting that right on my resume on LinkedIn, like master of price feeds.
That's it. Easy. So easy, My grandma did it. She don't even
I
have
actually like this a lot. Like, the developer experience here is very, very nice and smooth. You just import and there's a function. You read it. That's it. Love it.
Yeah, really. Well, that's where I have my basic, like, if I had a Tinder profile, this is my best face forward, and then you get into it, right? And so now we're gonna get into the dirty. Now you're gonna see the luggage that I got. So now we're gonna hit that second guess. We're in random numbers. Random numbers are a bit more intense, right? Because they are request response, and they look a little bit scary. Oh, is this what?
We are blocked again.
What? I'm gonna redo this one again. I'm gonna make it. These are all public. This is crazy. Let me see. Publicized. All right, I'm gonna make another one. I don't know what's tripping about it, but I'm gonna do it again.
In anticipation of the third one, that is also looked like it's.
Oops, let me get this thing. Apologies. I'm gonna just go ahead and jump the gun and like do it for the third one.
See, Billy didn't actually want to share his amazing code with us.
That's it. Shh. I just wanted to see my best foot forward on here. All right, let's see. Let's try this one. Good thing I didn't make a QR code with all these things. Hey, come check it out.
That would have sucked.
Yeah. Everyone's like, hey, wait a minute. What's going on here? See if that one works.
Right. No.
What's
going on? Okay, hold on. Maybe I've just been copy and pasting incorrectly. When I clicked the link, it worked.
Oh, okay. All right. So let's just copy that into Remix. Let's break it down piece by piece on there, because this looks scary for anybody that's trying to get into QRNG random numbers. And actually, like that's literally how I got into API3. I was deploying like this project that wanted to use random numbers on XDAI, which was now Gnosis Chain, and Chainlink didn't support it, because I was really comfortable with the random number system. And I'm like, okay, well, what about chains that don't have their support, right? And that's how I learned about API3. And I thought the docs were pretty good. And, at my level of solidity at the time, it was, I would say, not as good. But being able to like get this and read it, it felt good. And then I got to meet the team, and lo and behold, now I DevRel for them, right? Nice. But let's break it down function by function. Let's go ahead and minimize.
So I wanted to just like call that out for folks.
Yeah.
Build stuff, play around with the tech, and then somehow you'll end up working for people.
Yeah. It's crazy how that works out. Yeah. So let's just go by function by function. Let's minimize all the functions, so you can see it's like literally like 3 functions to make this work. Yeah. 1, 2, and 3. Yeah. So literally, to get a random number, it's 3 functions. And a lot of this is boilerplate code. You're not really going to touch too much stuff of it. It's kind of set up for you to go. So the first one is like set the request parameters. what chain are you going to use? Are you looking for one random number or an array of random numbers? Right now I have this set up only for one number. Okay, so once you set it up, who's going to pay for the gas? And I'll get to that in just a little bit. And then you're going to make the request. I want to get a random number. So you're going to make the request. It's going to do what it needs to do. And then it's going to get that number. It's going to fulfill it. So when you get that number back, it's going to give you that number. And that's it. And then from there, you get to do whatever you want with your number, with your logic. And so a lot of it just looks really, really scary in the beginning because you're like, whoa, there's a lot of code when I could just use block time, timestamp, rando, or whatever, you know? So it's a big jump, right? But overall, that's pretty much what it is. And the part that pays for the gas is the problem. So again, because it's multiple transactions, we have to do a request, and then there has to be an event emitted. And so we're, you know, in the front end, you're going to have a listener event or something. And then when you get your response back, depending on the chain you use, it becomes, you know, an issue like, hey, do I want to, you know, wait 5 blocks or do I want to wait 10 blocks? It all depends on the security of each chain. So it varies from chain to chain. On testnets, for this case, I think Sepolia testnet is the fastest. It does like 1 block. So like instantly you're like, okay, I got this, comes back. But for security, we don't want to do that. Like if you're doing on a mainnet with real money, you have $1 million on the line, right? You don't want to wait 1 block. You want to wait like 5 blocks. All right. Okay. 5 blocks pass. They can't roll it back, or it's very expensive for them to roll it back. And now we're going to send you that number, and then you can do whatever you want on there. So you just like have a longer loading screen. All right. So let's go to the top. Let's break it down. And then we're going to get a random number on here. All right. So on the very top right here, I have all the links for everything that we're going to need. So like the docs, basically the chain we're going to use on, the providers, and then how to get your sponsor wallet. And pretty much all you need to do is import number 8 is going to be that request response contract. And that's how it works. We're requesting a number. We're waiting for the response. So it's just a 2 transaction deal. Here we just have public variables. AirNode is our system that we're going to contract interact with. The endpoint is what kind of number system do we want? Do we want a single number? Do we want multiple numbers? And we'll see that in the docs. And then the sponsor wallet, right? So because it's a 2 transaction, you know, kind of system, when we send out our transaction, our wallet pays for the gas, right? But then when we get the number back, who pays for that gas, right? So somebody has to pay it. Like if you're into meta transactions, you'll realize, okay, the relayer will then pay for the gas. Well, this is basically our form of a relayer that's only sole job is to pay for that gas for that number that comes back. And then what you do within that same function in that gas transaction when that number comes back. So that's what the sponsor wallet did. They're sponsoring the gas. And then I created this QRNG value that we can just publicly see what the number is when we get it back, because you don't have to do it, but it's nice to see, oh, okay, did I get a 5 back or whatever on there. And then mapping.
Sponsor wallet, who funds that?
We do. We're going to fund that today. Yeah. So like if we do it, like Sepolia is the fastest, so I would say let's do it on Sepolia. I have Sepolia ETH, so just in case on there. Cool. All right. And then mapping. So let's say, you know, we have, you know, 10 people using our DApp for our game, and they're all requesting random numbers. Well, who gets what number back, right? Because, you know, Solidity and the contracts work atomically. So they all happen to hit send at the same time. Minor transactions 5 at the same time. So we just keep track of who's send what transactions. So request ID 1, 2, 3, 4. It's set in bytes. So we just got to make sure, like, are we expecting a number to be fulfilled in our request? So we just have a mapping for that. And then we have 2 events that basically said, hey, we're requesting an ID. And then we have another event, hey, we got the number back. That's it. And then a constructor that lets us know that which air node we want to hit to, like what chain are we going to go on? That's the air node we're going to do. Because remember, we deploy each contract per chain. So each contract is chain specific. They pretty much work, you know, deterministic. So most of our addresses are exactly the same on every chain for that.
Got it.
And then, you know, we can just open up these functions. We could set the request parameters on here. And basically we want to say, hey, what's our air node address? What's our endpoint address? And then who is the sponsor wallet, which we have to generate, which requires a bit of work. And then the make request is pretty boilerplate. It's basically a whole bunch of stuff like, hey, we want to request to our air node. And so we have all the details about our request is basically our contract, who's paying the gas, and then what function are they going to do? They're going to call back with. And then we're going to make, hey, you know, you're going to say requesting. And then we go back. Once we get that fulfill function in, we can expand that. It's all right. Now, are you expecting a number on this request? Would be like, that's why we have that mapping. Otherwise, we're just wasting gas. And then, we're saying, hey, we got it requested. And then we decode the data, and that QRNG value equals ABI decode. We're getting that data back. And then that is our actual number. And then in the comment, do what you want with that number, right? Like if we're playing a game, if the value is between 1 and 10, you get a 10, you get the grand sword. If you get a 1, play again, right? Anything GameFi that you can do that requires randomness. And then we're just emitting that event. Hey, we received it. So for the front end, it's like, hey, they got something in there. Let's display something in the front end. So pretty straightforward. It looks scary because there's just a lot of text on the screen, but let's get a random number, and then you're gonna see how difficult it is. You'll see the baggage that it has sometimes, and it's not difficult. It's just a matter of running through it once. So for speed, and I know let's try to do Sepolia. If you need some Sepolia ETH, I got you.
Ooh,
oh, you're rich. You're rich.
I am so rich.
Yeah.
I just need that on mainnet now.
There you go. There you go. So let's just shoot it out there, and then we're gonna take a few steps on here. And if anybody has questions, I'm not sure people are watching live, but we can drop in the comments or anything, or if you have questions, Rahat, go for it.
So far, I think I'm good.
All right.
All right. So we need to deploy this with an AirNode address, right?
Correct. So we wanted to see what chain. So on that first link on there for chains, I think if it's command or control, we're going to go to the chains. And so there are multiple chains and multiple things. So like, remember I was talking about different random numbers. So on the very top, like if you scroll up, just so people don't get confused, you did the cheat hack, right? For Sepolia. But we have the ANU random numbers, which the Australian National University does quantum. Those are what you do for mainnet, right? So if we scroll down, those are all the mainnets, and those are just some of the chains we support. Then we have the testnet ones, which we work on there. And like, again, you can look at the block returns on each one of how many sort of, confirmations we need before we get that number. But if you scroll past that, we also work with 2 other sources for random. We work with Quintessence, that also has another source of random numbers. So if you're not feeling the ANU, or you're like, I don't know if they're legit, we have that. And we also have quantum blockchains that do other random numbers. So you have 3 sources of randomness if you wanted to choose so. But for right now, we're just going to stick up to the testnet one on the very top with your cheat code for Sepolia.
Is there a reason why someone would choose one of these over the other?
You like their way of picking random numbers. Like, if you have a source of saying random.js and then there's an exploit on it, well, now, you're in trouble, right? But like, I like the way, Australian National University does is like true gravity and just like, whatever it is, and a random ping pong, like falling randomly. It's just like, I like their style. Quintessence, I don't know how they get their form of randomness, but like, they're all expensive. This is all out of my price range to get random versus downloading an npm package that says random.js or something. So yeah,
just write a JavaScript script and then call it a day.
There we go. And so we'll just go ahead and grab that address right there for chain. There we go. And so we're deploying it on that chain. So now our contract knows, hey, we're deploying it on Sepolia. We'll go ahead and transact it. Cancel that. That's weird. Did we compile it?
Pretty sure. Maybe I just need to refresh.
Yeah. Sometimes that happens to me on certain chains with the RPCs.
Yeah, I feel like the RPC probably did an update or whatever it was. It compiles. Switch this back to injected. I'm just going to confirm I am indeed on. I'm on base Sepolia, not Sepolia.
Ooh.
That's what it was.
Dang.
No Sepolia ETH.
Okay, drop your wallet on here. We're just gonna do this for speed. I'm gonna hook you up. Make you rich.
Oh, yes.
Let me.
Wow. So I commented it on YouTube. So all of YouTube now has my address.
Your dev account.
It's all good. But I will also send it on the private chat. We are professional streamers here.
That's what we do here. Let me send that out. Boom. You'll be set here. And we're just using Sepolia for speed. Some of the test nets do require confirmation, but because they work a little bit differently than ETH mainnet, sometimes it takes longer than it needs to. And we're not trying to bore you for like a super, super long time. I like base too. I did them for the hackathon on at Istanbul,
Mm-hmm.
and they
Let's
I
go
deployed.
to ETH. How do I bridge this to mainnet?
You could through what, layer 0. But yeah, I got salty because I created like this whole like air node to create like a sports betting DApp on Base.
Mm-hmm.
And like I didn't even get an honorable mention. I think they gave the first prize for some like random meme token thing, and like I got so salty I took it all down. I was like, hey, keep your air node.
Meme tokens are all the rage now, man.
Yeah, I was like, what? That's crazy. But yeah, all right. So now we can deploy.
We can. Let me just recopy.
Yeah, and you'll see like a lot of those contracts all look the same, unless like one of them was already taken or something. They're all pretty much the same across all chains.
All right.
All right, and now here's where it gets. This is where we're gonna get funky right now. All right. This is where people are going to take out their pen and paper on this one here. Okay, so first thing you want to do.
I've got my alchemy pen and paper here.
There you go. They didn't send me one.
Cool swag.
Yeah, they didn't send me anything, you know. But you know, I'm not hating, but it's all right. I'm not going to send them my API3 drip. No, that's it. All right, so we got to set up our parameters, right? We got to tell our contract what we're looking for and what we need, right? So in that second link, right, we got our air node, endpoint address, and sponsor wallet. So that second link, like these are parameters, right? So again, if we're using ANU, they have their own set. If we're using testnet, they got their own set. So we scroll down to the testnet, right? Air nodes are right there. Just copy that bad boy, put it in there. Easy. Nice. And then endpoint ID, we're going to go back in there and get that endpoint. So now this is a major breaking point, because if you want one number, endpoint ID UN256 is where you want to go. If you want an array of random numbers, like say I want 10 random numbers, well, now we're going to get endpoint UN2 array, right? So depending on how much gas efficiency you want or what you're going to do with your numbers, that's going to make a big difference on there. So like I'm making a game where like I want to throw a rock at somebody and they have a shield. Well, the first one is like, how much is the rock going to hit for? And then the shield, how much is it going to defend for? And those are two random numbers on there. So I can use two of them on that same transaction, and then that transaction goes through. You can use a ton. It just depends on how much gas you want to spend.
Within the array, can you specify like ranges for each of those numbers?
You can modular, and then once you get the numbers back, then you can do something in the function to do so. Because these are all 18 decimal numbers. So like it's a huge number. You can modulate. Like, so if you're doing 1 out of 100, you can modular 100. And then with those numbers in the array on that specific point, then do whatever you need to modular that one or whatever. And then you can change that.
Got it.
Yeah.
Cool.
All right. Sponsor wallet. All right. This is where it gets kind of funky. Okay. So there, that link in there for that mint CLI is there, but let me just quick link it to you here and pop it. So that docs on there takes you right to it. You can take to the admin CLI, but we need to derive a sponsor wallet address. And what does that mean, deriving a sponsor wallet? Well, we don't know how to sponsor it because we didn't know what our contract was until we deployed it. And so now that we've deployed it, we now have the contract that we need to sponsor, right? So on this derived sponsor wallet address, we need to then fill it out, run this script on your terminal, and it will generate you that. So what it's looking for on there, and there's examples on there, is looking for the extended public address, the air node address, and then the sponsor address on there. So I like to use a note, like a notepad, and then paste it, because then I have to erase the xpub and then put an extended public address in there, and then erase that. So I just use like a notepad or whatever on there, so like a text editor, to copy and paste it down and then put it in my terminal.
All right, here's my new note.
Okay, so I just paste it down, and then we're going to get some stuff. So we need to get the extended public address. Guess where that is? It's in the provider thing that we were just looking at in the providers tab, and there's the extended public address just underneath the air node, right there.
And that goes
on that first line. We're going to get rid of that example text. Oh, sorry, that second line right there, that xpub with ... Nope, we're going to go right there and paste it, and then we're going to add that space slash, so then the Mac knows how to like and go to new line. Okay, and then we're going to get that air node address, which we happen to have right there as well. And for people like this sucks, like when you use a framework, I have it in a JavaScript, right? So like I have it already pre-filled, but since we're doing it on Remix, we kind of have to do it manually. So there's tons of examples on the ecosystem of like having it like a hard hat framework or Foundry framework where it's just ready to go. So our sponsor wallet address, that is actually our deployed contract. That's the one that we don't know. So if we go back to Remix and grab that address of our contract deployed right there, boom, then we can add that there.
Going to the wrong thing.
Yeah, I do it all the time. That's why I'm like, I hate doing this manually. So that's why we have scripts.
Yeah.
Yeah. And so now we can copy that in, pop it in the terminal. You might have to do sudo on there just in case, because you have to install that AirNode admin on there, depending on the permissions of your terminal.
Let's find out.
Yeah.
Okay.
Yes. You'll have to install it. I'm just going to download it. Let's see. The moment of suspense. How secure is Rahat's Mac right here?
Not secure at all.
And so you can see that we've generated a sponsor wallet address on there. What I am campaigning for those that like to use Remix or third-party tools that don't have scripts, is like maybe like a little website where you could just pop it in your contract address depending on the chain, and then it'll just generate for you. But for now, you got to do it manually. And so you're going to get that sponsor address and paste. Okay, so we can transact. We can send that, hey, this is there. One more catch to this. Remember, somebody's got to pay the gas. So go ahead and confirm that. You can confirm that. So we got to go to the Protocol Explorer. It's just easier. We could just send it, but we want to send a little bit of gas to fund our return transaction to that sponsor wallet, because the sponsor wallet was going to pay the gas. So if we open up our Metamask and just say for this transaction, we're going to send them like 0.1 ETH. You can send that over. Oh, you could pop in the address of the sponsor wallet right on the top. Yeah.
Okay, wait, I'm confused.
Oh, right in the search address bar.
Oh.
Go ahead and paste in the address for the sponsor wallet.
And that's the one we got from here. Okay.
So it basically has nothing, right?
Yeah.
So we're just going to get Metamask, and we're just going to send like 0.1 ETH on there. And we just want to have that as a reference, because this is going to be the second contract that will be handling. So 0.1 will be more than enough gas on there.
Cool. So this sponsor wallet is what is going to be covering the gas for the return.
Yeah. And it'll also do the secondary transaction. So this is like our relayer on there. And so for those that like really want to get into AirNode, this is pretty much like how we cover gas transactions when you want to push something off chain, on chain. This entire system that we're doing with random numbers is basically how you would run your own AirNode. So when I ran that like stats profile, it was just calling an API, and I wanted to pull that on chain. The sponsor wallet is what pays for that transaction, bring that on chain, and then do whatever logic I want to have on there. So once we have that, we should be in good shape to actually request a number. So we're just going to make the request. So we're going to call that make the request. And we're going to shoot out to the air nodes and the EVM gods saying, hey, we want a random number. And then now we have to wait for that transaction to come through. We got to wait one block to make sure that they got it. And then we got to wait another block to make sure that it comes back. So if we check our sponsor wallet on that Sepolia, we can refresh and you should see the transfer in. So you see the balance. So it really depends on the block speed. It really depends on like how fast blocks are being mined on each chain. So Sepolia has been pretty decent as of late. That's why I wanted to stick with it. If we refresh, we should see eventually it will fulfill our transaction. And this is our waiting time. We're in our front end. We're basically waiting for that listen on event to happen of like, oh, when it gets fulfilled. So right now we're on this loading screen, you know, generating your random number or rolling the dice or opening the treasure box. And then you have an animation to buy some time. And then every so often, you're just going to want to like listen in. If we happen to go to our main contract, you can also listen to events on there. So read the events like, okay, I requested it. Did it get fulfilled? And basically watch it through the events. For any other like functions that you do, it's pretty event based. So you can always do things back and forth on the events. let's see, we just got to wait a little bit. So like if for right now, we could probably get 0, but if we go down to the QRNG value towards like the very bottom of Remix on the left-hand side, that's the number we're getting back. It should be 0 right now until we actually get it fulfilled. So the value is 0 until it updates. And this is what we're talking about, waiting transaction blocks now. Like, okay, I've had the transaction block. I can't game the system anymore until I get that number back. So maybe it should be enough time on there to get that number. Let's refresh and see if it's been fulfilled. It's still taking a little bit of time, depending on gas. It's supposedly super packed right now. Otherwise, we might have to fund it with a little bit more gas.
Yeah, I saw when I was doing the transaction, said network's a bit busy.
A bit busy. Yeah, it's supposedly everybody's awake now. I'm gonna fund it just a little bit more. Let's like send another 0.1 ETH into it just in case it has enough gas to pay it back. And I was just trying to do the bare minimum because there's a way to get your gas back from the sponsor wallet on there, but that would require a little bit more. Oh, no, it fulfilled. Forget it. Scratch that. We just were impatient. It took 3 minutes to get it back. So we've now basically got that number back. So on our contract, we now have that number.
So now if I do QRNG value, there is my
huge number, which you can then modular or do whatever you want with that number. And now with this number, you can do whatever you want, right? Like you can cut it up to pieces, you can modular it, and then do something fancy. And so even though I said I was going to do it early, let's try that GitHub GIS for the last one. That's random numbers. And then it's just a matter of putting them all together and then putting it all in one simple contract. So that third GIS from the top.
Higher, lower example?
Yes, that's it. So now we have like this game that we have mixing the two, the DAPIs, mixing the QRNG, and now we're like kind of creating like this dice game in a sense. Are you higher or lower than the number that's going to come out? And we know it takes 3 minutes to get a number now at this point based on traffic. So let's really quickly break down the code. Let's make it a little bit larger because it's kind of rough to see on there. I'm getting old, my eyes, I don't know. All right, so now we're mixing the two, right? So now we're bringing in, if we look at the imports, we're bringing in the RRP requester for the random numbers. We're bringing the iProxy from the DAPIs, and then we're just bringing in Ownable from OpenZeppelin, right? And so, you know, we have the same events, right? Request IDs. Now I'm adding some global variables for my game. So I'm creating this like lottery pot. So like the value of whatever the pot is in the contract and the minimum price that I want people to play in, right? So I'm making that, I want to say the minimum I want is $20 in ETH. So I'm going to put 20 ETH, 20.E to the 18 because we all working in 18 decimals, right? And then it all should look familiar, right? The price feed is the proxy address. The air node is the air node address, endpoint, sponsor wallet, and that QRNG value, right? Like we're literally taking those chunks out and then just popping into this contract, right?
Right.
And so have a few mappings. So the pending request IDs are the request IDs that was like, you know, did I do request ID 1, 2, or 3? I have a mapping of the players, right? So like the player, the way it works here, and this is where it gets a little tricky and a lot of people lose concepts. Like I send the transaction, my wallet sends the transaction to request a number, but the sponsor wallet, let me get my hands right. The sponsor wallet is the one that pays the gas on the return, right? So they're theoretically the message sender on that return. And if I'm trying to reward the user that did the original transaction, these message senders don't match. So what I'm doing is, okay, with this request ID that I'm doing, request ID 1, this is the wallet that did that request. So that's what that mapping's for, to map the requester from that wallet, right? And then the other one is mapping of just like who made the guess, right? Who's doing the guess? This is like, all right, if I have guess 1 through 10, who did guess number 1? Who did guess 2, 3, 4? What number did they guess? Pretty much. And then same events, requests sent, request received, same constructor, set proxy address, right? We're setting the price value. We're reading the data feed. So the data feed, I want to get a little bit more into that on line 44, is the data feed that we have is default int 224. Just because we have it, it could be negative numbers, could be positive numbers, right? So here I did a quick conversion where I convert the int 24 into a uint 256. So then we can use it with our DApp. So it's just a typecast conversion to return it. So we're not having a typecast through the whole entire DApp or anything like that. And I have those examples on the repos as well. Then if we scroll down more, should look really familiar. We're setting the request parameters, right? Making the requests, and then, fulfilling the request. And there's a couple little changes that I did on that from the make request. If we scroll down, I should look exactly the same, except for that one note part is we're keeping track of who sent the request ID. Remember, I'm like, all right, when I make the request, hold on to that message sender in a mapping. So then when we get it back, we know who sent it. And then when we fulfill it, it's going to come back at us. It looks exactly the same on that fulfill. If we scroll down just a little bit more, basically we got that same, setup. Do whatever you want with that number, but this time we're calling a custom function, which is distribute prize. So instead of having a separate function on there, when it fulfills that number, I'm calling another function to do all my logic and then distribute the price. And that's the only thing. So I'm using that same framework, that 1, 2, 3 framework, and I'm just adding in my custom function in order for it to be called. So then it just automatically goes. So I don't have to like, oh, a number came in, let me do something, right? It just automatically plays. And that sponsor wallet covers that gas. And then on the bottom, we have the place bets function right here. So this place bet is basically my logic of, entering the game. Right now, like in the front end, it would be like a dice game, right? Are you going to get a 6? Are you going to get a 5 or whatever on there? And so we're placing the bet. We're letting the user choose the number, right? And so what I'm doing is, all right, as long as the price feed is above $20, they can play. So I'm using the price feed, the DAPI price feed, to then check to see, all right, what is the minimum price of $20 in ETH USDC right now, right? And so I'm doing a little calculation on 93, where it's the minimum price, which I set was 20 E18, right? $20 times E to the 18, because we're working 18 decimals, and I'm dividing it by the price that I got returned on my ETH price, right? So remember when we did that request, it was like 2,500 with 18 decimals, and then my minimum fee is $20 in 18 decimals. So then they're subtracting each other, taking that 18 decimals out, they're negating each other. So I'm just adding another 18 decimals to make sure that I have 18 decimals to compare it to when I actually said my message value. That was a lot of decimal talk, but did it make sense?
Okay. So here you're just taking the $20,
yeah,
dividing that by the ETH price, and this is the ETH, the amount of ETH that we need to basically cover this bet.
Yeah.
Okay.
So based on whatever ETH price is, if it's $2,000 today and it's basically $1,000 tomorrow, then we know it's half the cost, right? So we know that there's a minimum set that we want people to play this game. And then I just do a require, message that value is greater than or equal to at least $20 in ETH. That way we can check. So we're using the price feed to just basically read it really quick. Is it more than the value? All right, keep it going, right? And then we just add our deposit to the pot. And then we put our guests on the mapping, and then we immediately play the game. So you'll see on that place bet, I'm calling that make request. So basically it's a one player only. You're playing by yourself. You're playing against the contract. I'm placing my bet. I'm making the request. It's sending out, right? So I'm just calling that initial function of the make request.
Got it.
Yeah. And so then it sends out to EVM land. The miner is like, oh, how can I game it? Obviously I can't game it. And then we just wait for that number to come back, and then we're going to do our custom logic just below that, which is distribute prize. And basically it's going to go and basically get that return number that we get, whatever number we have, and then it's going to fill it with the player address. Did I win or lose, right? And so it's going to look at my number to see what I guessed as my first function, and if my guess is higher than the return number, I'm going to pay out the pot. The pot goes back to 0. I'm going to delete my guess, and then the game's over, right? So the contract is simple enough where I'm like, all right, I want to place a bet higher or lower. Is it going to be higher than 10? I place 11. And then as soon as I place my bet, runs to the contract, gets a random number, comes back. If I win, it pays me out the pot. If I lose, the pot gets bigger.
Okay.
Very simple. So using all the pieces that I have looks really scary in the very, very beginning, right? Because, I got to do a price feed. Right. I got to get a random number. But now that we've had it all piece by piece, we're just adding 2 more functions, right? And then those functions, we're just doing calls to those framework, and then we're good. So like if we will launch this, we'll have to take it all step by step. Now I kept them separate to be easier to like, okay, I can mix it together. But our initial setup can be one function where we set the price feed, the random number stuff, like all that. But I just set them separately, so we can like, okay, this is how price feeds work, this is how random numbers feed, but we can deploy this bad boy right now and bid it. Oh, one last thing on the very, very bottom, I added it just for fun, is the receive function. It's something special to EVMs and smart contracts, right? Smart contracts alone cannot receive ETH. Like if you didn't have this receive function, the special function, I would not be able to send ETH directly to the contract without some kind of, you know, payable function or anything like that. So just for fun, like if I wanted to up the pot, I wanted to send ETH to the contract, it'll just increase the pot size. So having that receive or fallback, or fallback, you know, that's how a lot of people do reentrancy attacks. So I just added that in for fun. So if someone wanted to juice up the pot without playing, right, they can add it. So like if I had my DApp and I wanted to start, you know, 1 ETH is the grand prize, get people to start playing, then that's how I would do it with the receive.
Nice.
Yeah.
Cool. Let's compile.
Yeah. And hopefully this all works, because I did this last night.
All good. All right.
So now I'm going to let you do your homework now that you're a master of random numbers in QRNG. Here we go.
First, we need the AirNode address, which was here.
That's number one confusion that everybody gets. So
okay,
that is technically right. But if we look at the chains, we have to just decide what chain we're going to go on, right? That's how we're deploying for. So it happens to have the same name, which drives me absolutely nuts. But if you go to your first tab right next to the remix, those are the chain AirNode addresses. Yeah. Yeah. That's, I want to fight the core devs that named him. They're both called AirNodes, but the first one, anytime you deploy a contract, you want to tell the contract, this is the chain you are on, right? This is the AirNode chain that you're going to.
All right.
Yeah.
Cool. So now we're good. We're going to transact and deploy.
Yeah.
Confirm.
Then we have that awkward silence and just hope that everything works.
Just hope that Ethereum works.
Yeah. All right. Now we got to set up our contract. You know, we got to set up our price feed. We got to set up our AirNode setup. You know.
So that's going to be, we're going to set the proxy address for the price feed.
Yeah. And I left this public for like everybody. Like, again, a lot of these things could be internal, but for debugging and testing purposes, like if you're testing on Remix, I like to have all the functions available to me so I can run stuff, you know, when I need to.
Cool.
That's for base testing. So we want to go to Sepolia. Yeah.
Sepolia. So now that's over here.
Okay. Yeah. A lot of people get confused.
Look at me. I'm like already an expert on API3DAO.
That's it.
Okay. So now I've got the proxy address. Now we got to set the request params for these. All right. So that is actually on this page. So we need the AirNode address, which is this AirNode address. We need the endpoint ID, which was also on that page. Sponsor wallet we get by doing that weird thing.
Yeah. That's why I keep your notepad open. We did that CLI thing.
Yeah.
Yeah.
All right.
And so the only thing that changes on this is your deployed contract, and that's what changed.
No,
everything else stays the same. Yeah. So this one goes a little bit faster, right? Okay. And it should be faster because you downloaded it. Boom. There we go.
What's going on with my computer? Okay.
You're 10 times engineer now, so like it can't keep up with you. That's it.
All right. So these are our request parameters. Get transact, confirm, and I believe that's all the setup we need.
So close. And this is where I've made multiple mistakes. We got to fund that sponsor wallet.
Yes. Yes.
Yeah. Somebody's got to pay for the gas. So every time I run a transaction, why isn't this working? That's what happens. So I grab that sponsor wallet address, I throw a little bit of MetaMask in there, and I like to look at it on the Sepolia testnet.
Send some So 0.2 or 0.1.
Yeah. Yeah, I'm usually cheap. Now there's a script because there's a special way because that wallet is theoretically an EOA. There's a whole thing that I can get really deep, but we're out of time on that. But there's a way, there's a script that you can get that money back from the sponsor wallet because right now there's no way to get it. But we're going down like script land and a lot of random stuff. So, you know, in the docs, or you could just ask me, you know, hey, what's the script to get the money back from the sponsor wallet?
Gotcha.
That way you don't have to like be like calculate, oh, if I want 3 transactions, can I do it? You could just overfund it, and when you're done with it, or if you're done, you know, done testing it, you can just pull it back. Yeah.
All right. So that is funded.
Okay.
Now we're good to go.
Yes, we're ready to rock.
All right. So now I want to place a bet.
And so if we look at it really quick, you'll see that my QRNG value on line 81 is modular 5.
Okay.
So I'm already hard coding it to be like, we know the number is going to be less than 4 because it's going to be 0, 1, 2, 3, 4. So if you bet any number above 5, you're going to win.
My money.
I rugged you. So we know, like, for sure, like if you go 6 or something, and again, you would obviously make sure that your bet is within range of what's fairness, or have obviously a much wider range. But we want to make sure we win, right? So if you do 6, 7, 8, 9, you know you're going to win, and that's in our red button on there for place bet. We're going to pick our number.
All right, I want to win.
Yeah. And so we also have to make a payable on there. And so let's do a little bit of calculation on here. And I hate the fact that I can't do like 0.1 ether. I have to do everything in way. For some reason, I can't do decimals on ether in Remix. Can you? I don't know.
Yeah, I think you can. Ether.
Let's see. On my machines, it will not do so. I cannot add a decimal. I can do 1 ETH, but I can't do 0.
No, I can't do a decimal. Hold on.
Yeah. It is a
Remix,
nightmare.
Please fix this.
Yeah. So I work in Way. So I do the Gwei to Way converter, or like I just Google Way to Gwei or something, and there's a converter there. So just doing some quick maths, right? Like, what is the price of ETH right now? Let me go into our good friend CoinGecko here. And we know ETH is 25.24, right? So getting a little bit of calculator, $20 divided by 2,500 is a rough estimate of 0.008, right? So if we do anything below like 0.006,
and not put a point here either.
Yeah, 0.006. Yeah, you should be able to.
Yeah, wait,
so,
maybe that's how you do it on Remix.
Okay, let's see.
Oh.
Yeah, I've been struggling. It used to work. I don't know what changed. I thought it was me. So that's how much we know for sure. Yeah, so like for sure we're gonna get that, and we send it in, and it's gonna work, right? So like if we paste that in there and you set your bet, that should work.
Let's go.
While we're waiting for that transaction, let's try to place another bet just because we're crazy, but let's do it below threshold. Let's do like 0.005. We know that is less than our $20.
Oh, you mean like?
Yeah, like in our bet. We can put whatever number we want, but we're gonna know it's gonna revert, and we should get a revert warning. I don't know what happened there.
Okay, I'm gonna transact that again.
Yeah, make sure your way is changed on your transaction.
Oh, whoops.
There you go. Yeah.
That's what it was.
Yeah. And so like just 005. I don't know if you can change the number that easy. We'll see. I changed it there. Yeah. On the very bottom, just change that 5. Every time I modify a number, the JavaScript machine just like goes all the way to the very left. Why? I don't know. But theoretically, we should, should give you a warning saying, hey, it's going to fail because it doesn't meet the requirements of the price feed. It's checking the price feed. Hey, it's not worth enough. Kill it. So we know that we're getting at least $20 of value at the time that the ETH price feed is. That's all I wanted to cover. That's it.
Gotcha.
So that way you can easily check, okay, I'm making sure that people are paying just under that. So like if you want to keep a game $5 for every time you want to buy an item, but ETH is like 4,000 today, 3,000 tomorrow. It's always $5 for the client, right? So that way they're not guessing inconsistencies. You know, you said something for 0.1 ETH 3 years ago was way different than the price it is today. So like once the contract's immutable, you want to make sure that, you know, you have a consistent price for everybody across the board. You can always say, hey, it's always going to be $5 no matter what the price of ETH is going to be.
Nice.
Yeah. And so now we just play the wait game. We can check the sponsor wallet to see if we get it fulfilled. Excuse me. And see if it refreshes and see what we get. And boom, it fulfilled. So if we look into that transaction, we're going to see the details of it. So you'll see that it fulfilled. And then on the 2, it went back to the smart contract. And then you see that it transferred it over as well on that transaction breakdown. Okay. You see it like just underneath the 2, you'll see the transfer of ETH. So the winner got the pot.
Nice.
And so every time they play, you know, if you win, you take the pot. If you lose, the pot gets bigger. And then you just keep playing until somebody wins and empties the pot. A very simple mixture of price feeds, mixture of random numbers and getting back. And if we go back to the smart contract, you can check what the number was to see, oh, what is it? It's that QRNG random value. And then we got, what did it say? Oh, it's trying to read it. Eventually. Someday. Is that like Sepolia RPC value? In time, let's see. But it should be a very, very low number. Maybe try it again. If not, we can go right into the contract itself. If we copy the address, if Remix is tripping, if we scroll back and just copy that contract and then go to Sepolia, I think we can look at the events. I'm not sure if we can see that while it's on there. If we go to the events, can we see it? And received, right? And so we see that it's 2. Or am I blind? Is that 1? I feel like I'm in the optometrist. It's like, what number do you see? On the very bottom hex, all the way down, it's this huge number, but we modulated it to...
Oh, that's a 1.
That's a 1. So we got the number 1.
Nice.
Yeah. And so we knew that it was a bad boy, and we had it gamed, and we won the system. But yeah, that's pretty much API 3 tools in a nutshell of being able to, like, you know, figure it out, modularly mess around. You know, you have this framework. It's about how creative you can get with gaming or DeFi or any other thing that has prices or random numbers in it, right? Random numbers can be open to like gambling, gaming, like anything that makes gamification fun, right? Of like picking up a random chest, what do you get? When you pick a starter pack, what do you get? You know, it just adds a little bit of game to it on there. And then our latest project is going to be OEV, Oracle Extractable Value. Just to get a little touch into that for a little flavor. It's going to be, you know, price updates cost gas, right? So like if we were to price update 2,500 in ETH and then 2,500 ETH and 1 cent, it wouldn't make a lot of sense because we got to pay for that gas update on chain. So they have deviations, right? So like the standard for a long time was 1% deviation. So if ETH was 1,000 price and then it dropped to like 990, then it'll be, oh, there's a difference in price. Let's update the ETH code. Now I'll get to that example code in a second, Julio. So we know that, okay, 990, but let's say somebody was liquidatable at 995. We'd have to wait for the price of ETH to go all the way down to 990 for us to liquidate that position because it doesn't reflect on chain. It reflects on CoinGecko, CoinMarketCap, right? So it's like, okay, now we're just sitting there watching like, hey, I can't get this liquidation. So everybody's waiting for the price to drop, right? And then we're trying to go. So what OEV does is allows searcher bots to then push the update of the Oracle ahead of time. So if it's 995 and they get liquidated, they can push that update themselves and pay for that update and then do the liquidation. In alternatively making the price feeds better because other people are then paying for the price feed. So it's a little bit more precise. So that's kind of our latest product for OEV, like making price feeds awesome. You know, and then like you get that gets lost to MEV bots, right? Liquidators. So if the DApp does it, they can redistribute the rewards, right? They can fund public goods with that. You know, the liquidation was going to happen anyway. You were 2 degen, you got leverage, right? But what do you do with the funds besides giving it away to an MEV bot, right? You can reward the stakers, right? Or you can make your liquidations cheaper than 5%. Maybe it's 1%. Now people want to use your DApp because it's only a 1% liquidation. Even more degen, right? So like you max leverage it out because it's not so bad. So there's a lot of things that we're doing with OEV. That's going to be the big talk. I'll be doing a lot of workshops on that for Denver. So if we ever want to come back again, we can deep dive into OEV and price feeds on that. You know, now you see how easy the price feeds are. how to optimize it to update it externally. That'll be the new thing.
Nice. That's awesome.
Yeah.
Cool. No, I'm looking forward to that. Definitely will find you at Denver and make you teach me.
Yeah, I have a workshop coming on there, but let me paste this code. I have a ton of codes for our good friend looking for things. The github.com API3 ecosystem is where we do a ton of example codes. Like, we don't want to flood the main one with like the error nodes and the price feeds. So in this API3 ecosystem one that I just posted in private chat, it has ton of example repos. We're talking like the sports betting DApp. I'm talking about like price prediction DApp, prediction markets, like a Uniswap price checker before swapping, like making sure your price meets criteria before you swap using the price feeds, right? Instead of a time weighted average price. So like there's a lot of examples out there in the API3 ecosystem one that you can use to like verify, fork and copy, fork and go. Like I'm a big proponent of fork and go. So like if there's a layout or framework that I can use, then that's what I'm going to use in order to get that up and running and then start actually building my idea versus trying to mess with like, oh, how do I get a price feed? How do I get a random number? And spend one day of my hackathon trying to figure out the SDK versus like going with my idea and just flying because I forked this protocol and just went. So tons of examples there.
Nice. I'll also make sure to drop these links in the description. So for folks who are rewatching this, you'll have an easier time in getting these links.
Yeah, I know it's a lot to swallow, a lot like, oh, it's a lot to go in there, but you have the video for reference on there. I'm pretty chill. You can probably reach me out. I'm pretty responsive on questions. And then there's the Discord that was on that link as well. API3, or if you go to API3.org, it takes you straight to the links. We're pretty responsive. I don't think you're waiting more than like a day max on a response on there. We're pretty on there. I get notifications, so if I'm not sleeping, I'll answer your question.
Nice. Yeah. Awesome. Thank you so much for being part of the first stream, Billy. I learned a bunch. I learned a lot about random numbers, price feeds, and I'm gonna go build some gambling apps so I can like hit up some of your bounties at different hackathons.
There you go. My favorite. Let the DJs be DJs, man. I'm just saying, accept it. Just let it be DJs. Yeah,
cool.
But yeah, a lot of the focus has been on GameFi, right? Like random numbers and talking to chains about different ways to do it. And I mean, not to extend the workshop, but like the ability of adding a random number per block, so you don't have to request it, and it's just in the chain directly. With a lot of these new chains, has been a new idea that I've been kind of thinking like, wow, that's pretty cool. Like you could just use a number that's random on the next block without having to request it, for a much better gaming experience, right? So right. There's so much more to go. There's so many things that people are trying to do, and it's really exciting about like what the guys at API3 are doing. Like I'm really happy with the team and like what I get to do, and so I'm looking forward.
Nice. Yep. So for folks who want to follow API3DAO on Twitter, their handle is down here. Their docs are available at docs.api3.org, and you can also follow Billy at WC49358.
Yeah. I'm the weird bee. Awesome. Thank you for having me, Rahat. It was fun. Hopefully everybody following doesn't get totally lost. Hopefully we see more cool stuff out there. And if you need help, holler at me. It's literally my job.
Awesome. Thank you so much. We'll be announcing who the next stream will be in the next 2 days. So stay tuned and goodbye.
See ya.